بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 6.2 and it's about volumes. We will study two methods to find volumes of solids of revolution. This is the first one. We can say using disk and washer, this method. Uh, First, what is a solid of revolution? If we revolve or rotate a region about a line, we obtain a solid of revolution. So, for example, here we have this curve, square root of x, and we have this region, okay? This region is bounded by square root of x, the line x equals 1, and the line y equals 0. If you rotate or revolve this region about the x-axis, you will get this solid, the blue one. And our aim here is to find the volume of this solid. Well, to find the volume of this solid, we will use the same method as we did to find the area. We used rectangles. We divide the area into small rectangles. So we will divide the volume here into disks. This is a disk. You can say it's a cylinder, small cylinder. Okay. The volume of this cylinder, we need to find the volume of this disk or small cylinder. And then if we have infinitely many disks like this, and we add all of their volumes, we will get the volume of this solid. So we will have, it would be integral, the volume would be integral of the volume of the disk. The volume of any cylinder, okay, of this cylinder is the area of the base times the height. So the base is a circle, so the area of the base is pi times r square, where r is the radius, and dx represents the height. Of course, it's small. The width is, or the height of the disk is very small, so it's called dx. Notice that this rectangle, okay, this rectangle, when we rotate about the x-axis, it will give us this disk. Now, this rectangle is perpendicular to the line or axis of rotation. So if we're rotating about x or around x, this rectangle would be perpendicular to the x-axis. So the volume would be the area of the base, which is pi r square, times dx, which is the height. So that's why the integral is like this. We can write it integral from a to b, and the area we can write it's pi times radius square dx. Okay, so a is pi times radius to the power 2. Notice here that the radius equals y equals f of x. It's a function of x. Okay, radius in this case, if we rotate about, this is here about x-axis, we are rotating about x-axis. So when we rotate about the x-axis, the radius is always f of x or y. That's obvious here. This is Usually, how can you find the radius? This is the radius from the axis of rotation to here, to the curve. So we will use this rectangle, and the radius of the rectangle, or the radius of the disk, would be the height of this rectangle, okay, which is the height of this, and the height of this rectangle is y equals square root of x. Because if this is x, then the height is f of x or y or square root of x. So whenever we rotate about the x-axis, the radius will be a function of x or y. But if we rotate this formula here about y-axis, if we rotate about y-axis, then this formula also can be written as ay here would be, the area would be pi times radius square dy. But the radius in this case is equal to x, and it's equal to f of y. So it should be a function of y. Here it's a function of x because we are integrating with respect to x. Here it's a function of y, which is equal to x because that's the function. Usually f of y is equal to x, like here f of x is equal to y. So that's the situation, and this is, if you like, a graph also when you rotate about the y-axis. So this, now the rotation is about the y-axis. So notice that the rectangle would be perpendicular to the y-axis, and the radius of this disk would be the distance from here to here, which is the length of the rectangle. This is the radius. So the radius would be, in this case, x. This distance is x, and it is equal to function of y, okay, whether, because this function is y equals x cube, so we solve it for x, and x would be cube root of y. Let us have some exercises. These are the formulas. If you understand them and how to find the radius, okay, uh, it will be easy for you. So here, find the volume of the solid obtained by rotating about the x-axis. About the x-axis, we will use the first formula, okay? So pay attention. So let us write it immediately. About the x-axis, the formula would be the volume equals from A to B pi radius square dx, and the radius square is y equals f of x in this case. All right, this is the region, okay. uh, it is under the curve y equals square root of x from 0 to 1, okay. So this is the region. Now this is the typical rectangle. We use this rectangle to find the volume of this disk. The volume of the disk would be the area, okay, of the circle, which is pi radius square times the volume times, sorry, the height, which is dx. So the width of this rectangle, delta x, will represent the height. Okay. So what would be the volume? X is running from 0 to 1. We have pi. What is the radius? It is the height of this rectangle. It's y equals f of x. So it's square root of x. We raise it to the power 2 dx. That's it. So we can take pi out and we evaluate. Now square root of x to the power 2 would be x dx. So you write it x squared over 2 from 0 to 1 And do not forget the pi outside. So pi over 2 times 1 minus 0. So the answer is pi over 2. So that's the volume of this solid. Okay, that's the volume of the solid. Another example. Find the volume of the solid obtained by rotating the region bounded by y equals x cubed. This is the graph of y equals x cubed. Y equals 8. This is the horizontal line, y equals 8. And x equals 0. This is the vertical line. So you can see that this region is bounded by this line, and this curve about the y-axis. So we need to rotate about the y-axis. Once we rotate about the y-axis, the formula would be from C to D pi times radius square dy, where the radius in this case is x equals f of y. So y here, y, that the boundary of this boundaries of this region, y from 0 to 8. So the integral would be from 0 to 8. All right, pi is always there. And now, what is the radius? Draw a rectangle perpendicular to the y-axis, the axis of rotation. The length of this rectangle, or the height of the rectangle, let us say the length in this case, would be the radius. The distance, the radius is always the distance from the axis of rotation to the curve. So this distance is the radius. This distance is equal to x, and x is equal to f of y. Well, the function is y equals x cubed. So we have to solve it for x. So x would be cube root of y. So cube root of y is raised to the power 2 dy, and you evaluate the integral and you find the answer. So this is y to the power 2 over 3. You add 1, so it would be 5 over 3 times 3 over 5 from 0 to 8, and you find the answer. Now, the region R enclosed by these two curves is rotated about the x-axis. Find the volume of the resulting solid. So let us sketch the graph of this region. I have the line y equals x, okay, 1, 1, 2, 2, and y equals x squared is the parabola. So this is the line, while the parabola at 2 is 4, and at 1 is 1. The parabola goes like this, okay, y equals x squared. So this is the line y equals x, and the parabola is y equals x squared. Well, let us see what are the intersection points. X squared equals x. So x squared minus x is 0. So x times x minus 1 is 0. So they intersect at 0, 0 if you replace x here, and x1, y1. So as you see, they intersect at 0, 0, 1, 1. So let me assume that this is 1 and this is 1. So we have this region, and we need to rotate this region about the x-axis. What type of rectangle we are going to use? a rectangle that's perpendicular to the axis of rotation. So it would be a rectangle like this. And now, if you think of this region when it is rotated or revolved about the x-axis, in fact, here we are not obtaining a disk. We're obtaining something called washer, like this. Because this region, there is a distance between this region and the axis of rotation. So when you rotate this region about this axis, there will be an empty space in the middle. Okay, so it's called a washer inside empty. So now to find the area, okay, of this washer, we find pi times the outer radius to the power 2 minus pi times the inner radius to the power 2. So we have one outer radius, okay, from the axis of rotation to this curve, and the inner radius from the axis of rotation to this curve. Can you imagine? When you rotate this about the axis of rotation, this would be the outer and this would be the inner. So here is the axis of rotation, and the distance from the axis to this one is the inner, and to this one is the outer. All right, so remember the formula here. If you have a washer, it is not a disk, okay, because there is a space here between the curve and the x-axis. So when you rotate, it's not a solid like this region, solid like this, and this region, it's a solid because there is no space between the axis of rotation and the region. So the volume here would be given by, since we are rotating or revolving about the x-axis, so we will use delta x because also it's the width of the rectangle. So delta x would be used. So from A to B dx. And now we have pi, and instead of radius square, we have an outer radius, okay, radius outer, or let me just write it, outer radius square minus inner radius square times dx. So this would be the formula. And remember, the outer radius and the inner radius both are functions of x. So y equals f of x, y equals f of x, or g of x. All right. Now, how to find the outer radius and the inner radius here? Please pay attention to this important point. You start from the axis of rotation, from here, for example, okay? And you go to the outer, okay? This is the outer, the one which is further, okay? More distance, longer, this distance is longer. So this is the outer and this is the inner. The inner is to the first curve, the outer would be to the second curve. So think of this distance. What is this distance? Well, if this is, what is this distance? It's a y distance, so it's y, and it's equal to f of x. It is this line now, y equals to x. So this distance from here to here is just x. So it would be from A to B, from 0 to 1, x squared minus the inner radius. The inner radius is this distance from here to here, And the distance from here to here is the y of this function, which is y equals x squared. So it's x squared raised to the power 2. So it would be x to the power 4 times or dx. And you find the volume. It's easy to continue from here. So uh, you should always know that whenever you have a function like this, and this is x, so this is always f of x, and this is the point x and f of x, and the height is f of x. So the height always from the x-axis to the curve is f of x of that curve. Okay, and the height from the x-axis to the line is the f of x or the y of the line. F of x of this line is x. F of x of the parabola is x squared. Well, now we will go some uh, steps further, and we talk about, although these are additional examples, okay, we will rotate or revolve about lines, not about the x-axis or the y-axis. So the question, find the volume of the solid obtained by rotating the region in example 4. This region, okay. So we have 0, 0, 1, 1. This is the line, and this is the parabola, okay. So this is the region, line and a parabola below, okay. This is the region. And now we need to revolve this region about what? About the line y equals to 2. Okay, so we will go up to the line y equals to 2. So this is now the axis of rotation. Please pay attention. Now, once you rotate this curve about the line y equals to 2, you will obtain what? A washer, not a disk. Okay, so what would be the formula? The line y equals to 2 is parallel to the x-axis, and the rectangle you choose here has width delta x. So we are integrating with respect to x. Pi outer radius to the power 2 minus inner radius to the power 2. So how to determine the outer radius and the inner radius? Remember, you start from this line, the axis of rotation, and you reach the outer curve. Okay, this is the outer curve. So now think of this distance. What is the length of this line segment? Remember the important point we mentioned. If this is x, then this distance is f of x or y. So this distance, this small distance here, this is in fact f of x. Okay, so what would be the length of this line, the orange line segment? Well, from here to here, y is 2, so the distance, this distance from 0 to 2, this distance is 2. And I need the length of the orange line, and the length of the blue line is f of x. So the length of the orange line, which is the outer radius, would be 2 minus f of x. of the curve, and f of x of the curve is x squared. So this is the outer radius, and you raise it to the power 2, because this distance is 2, and we are subtracting the small blue distance, which is f of x. Okay, similarly, please think. Now, this is the inner radius from the axis of rotation to the first curve, not to the second. This is the inner. Okay, if I ask you, what is this distance from here to here? It is f of x. Of what? Of the line, which is x, because the line y equals x. So how to find the red distance? It is 2, all the distance 2, minus this distance, which is f of x, or x of the line, to the power 2 dx. So this is the volume, and we are, with respect to x, it's from 0 to 1. The area is from 0 to 1. So this volume will give you the integral. This integral will give you the volume. Of course, it's easy to evaluate. You can just expand this and expand this and find the integral. Let us find the volume of the same region, but now rotating or revolving about the line x equals -1. So this is 1, this is 1, this is 1, and we have the line and the parabola. We need to rotate the region about the line x equals -1 this time, about this line. It's parallel to the y-axis. And remember, you draw or you take a rectangle perpendicular. So this would be the rectangle perpendicular to the axis of rotation. So the dy, the width is dy. So the volume is given by integral from c to d pi outer radius square minus inner radius square dy. All right, we just need to determine the outer radius and the inner radius. Good. What is the distance? The outer radius would be from here to here. Okay, this is the axis of rotation. So from the axis of rotation to the second curve. What is this distance? Well, this distance is easy. This is 1. From here to here, it's 1. And from here to here, it's changing. Changing. This doesn't change. This fixed. But if you use this line, for example, this distance, which is this distance, how can we write it down? So it's a variable distance. It's not fixed. This distance is actually x. Remember, the outer radius here is x equals f of y. Here, x equals g of y. So it's x equals f of y. What is f? This parabola. So the equation of the parabola y equals x squared. I need to solve it for x. So x would be plus or minus square root of y. But we are to the right of the x-axis, so x is positive. So this parabola now has this equation, x equals square root of y. So what is the outer radius? Now, y is also from 0 to 1. Pi is there. The outer radius is 1 plus x or plus square root of y, because we have to write it in terms of y. We are integrating with respect to y. Good. Can you figure out the inner radius? Well, the inner radius is this distance from here to here to the first curve, which is the line. This distance is 1, and this distance is x of the line. The line has the equation x equals y or y equals x. So the distance is y. So the inner radius is 1 plus y. You raise it to the power 2 dy and find the integral. This was the last question. I hope you understood the volume, how to find it using disk and washers. If not, please say it again and again and again until you understand. Thank you very much.